Problem 934 asks to find a suitable aluminum alloy and the deformation given these conditions. Now, the original problem 34 had a different length, but that only changes the deformation aspect. So we have a force of 2,500 pounds, a length of 9 feet 3 inches. The tube has an outer diameter of 0.75 inches and ID of 0.563 inches, and we are told that it is a static load. So we'll have to look up a couple of things as well. So I'll put look up over here. But we'll get to that in a moment. We are trying to find a particular aluminum alloy, which means we need to find a design stress. So considering this is a static load, our design stress is equal to the yield stress of the material divided by 2. And we will set our design stress equal to the force over the area that's actually going to be on here. And that's 2,500 pounds divided by the area. Now we've got the OD and the ID. So the area is pi times the OD squared minus the ID squared all over 4. So if I plug those numbers in, we end up with 12,964 psi, and that is our design stress. So now we need to find a yield strength of a material. So SY over 2 equals 12,964 psi. Our yield strength of the material we're going to choose needs to be 25,928 psi. So essentially 26 KSI. Well, this alloy is supposed to be an aluminum alloy, so I'm going to choose 2014-T4, which has a yield strength of 42 KSI. This will give us a substantial factor of safety. There are several others that might be a little bit lower, many others that are higher, but 2014 T4 is not overly expensive, so I'm going to stick with that. So far, found an alloy. And I've got a reason why. 42 is greater than 26 KSI, which is our minimum yield strength. Now, next we need to find the deformation. Deformation is equal to the force times the length of the area times the modulus of elasticity. Well, we need to look up the modulus of elasticity for 2014 T4. That is 10.6 times 10 to the 6th psi. And we will continue calculations this way. We've got 2,500 pounds times the length, which is 9 feet 3 inches, which is 9.25 feet, all over the area which we found before, 0.193 square inches times the modulus of elasticity that we looked up. Our deflection is 0.0113. Oh, what do we have here? We need to cancel these units out. We've got inches squared times pounds per square inch. So I can cancel that out, and I'm left with pounds. And the pounds on top, pounds on the bottom. I'm left over with feet. 0.0113 feet. But when we're down to lengths of that size, probably going to look at inches. So if I multiply by 12 inches per foot, I'll end up with 0.136 inches. Just for fun, we'll calculate the strain. The strain is equal to the deflection over the original length, 0.0113 feet, all over 9.25 feet equals 0.112%. To recap, we were given a load, the dimensions of the cross-section, and a length, and the type of load, and told to find a suitable alloy, aluminum, and calculate the deformation. We needed to look up the modulus of elasticity and also the yield stress of the material, but we needed to look at the design stress first, calculate that, relate it to the yield strength that's needed. The yield strength needed was about 26 KSI. We found one that was relatively cheap and yet had a large factor of safety. We used the standard deflection equation, standard strain equation, and followed our units carefully to the correct answer.